Yeah, that was on last night's homework, I think. No, the homework before that. Yeah.
Remember?
Yeah. I know the homework got like mad deep. It's like mad questions there. Anybody else? Any questions from the homework? Anything I want to go over? Everything is legal. You good with the homework? No? You don't have any questions from it? Yeah, okay. Okay. So when you get a chance, log in. Let me update you guys on something. So next month, which is next week Monday, right?
July.
I think. Hold on. I forgot what day it is. Next week Monday, yeah. Is next month, right? So we're gonna have a new tutoring schedule. So my schedule is changing. I mean, our class is fine, but like the tutoring, my tutoring times are gonna be different. Um, Off the top of my head, I believe I'm gonna be in person Monday and Wednesday, and then online Saturday. That's gonna be like the big difference. Um, no, no. But like, if you guys want help, like please go. It's okay to get help from anybody else. Like I'm happy to help you guys, but you guys have a whole bunch of other tutors there as well that you guys can go to. The hours of tutoring are going to change, right? Now they're going to be Monday through Thursday in person from 12 to 6. And then it's going to be Monday through Saturday from 12 to 6 online. All right. So long story short, we lost Sundays. You know? Yeah, we had Sundays. So that's why I was telling you guys, like, go on Sundays, like, but apparently not enough people went on Sundays, so we lost that. But we still have Saturday, still have the Friday, but it's only from 12 to 6. All right. So again, like I don't expect you guys to do all that homework on your own. If you need help, go do it in tutoring. Like the best way to do it is to do what you can, and then if you have like one or two questions that don't make sense, bring that to tutoring and then ask them, and then you'll get through it that way. You know. What else is there to say? Today was pantry. I hope you guys all went, if you could. You know. Pantry's in another 2 weeks again, so if you miss this time, you can always catch it next time, kind of situation. Uh, nah, no class 4th of July. That's next week Thursday. Yeah. So next week Thursday we're gonna have our test, right? Then I looked at the calendar and it was like, damn, 4th of July. So we're looking at the week after, all right? I'm thinking about it. I don't really like Monday exams. Maybe like Tuesday or something. Like I haven't decided yet, but I'll let you guys know sometime next week when we're gonna do what we're gonna do for like the next exam. But for right now, all I want you guys to do, focus on the homework. All right. You guys have this weekend, catch up. I know a lot was dropped this week. Just do your best to catch up on everything, right? My goal for you all with the homework is I want you all to have 100 in everything, right? And just to reiterate, right? Like the homework is worth more than everything in the class. It's worth more than your test. It's worth more than the final, right? Do the homework. And I can't say that enough. Like do the homework. It's free. It's easy. All you have to do is just get 100 in it. All right. And by you doing the homework, that helps you with the exams. Like I can tell you that those who did their homework, they're the ones that got most of the questions right. Like I can see it in the exam. It's not that you guys aren't smart. It's not that you guys don't understand. It's that you didn't practice. That's all it is. All right. So there's that. I'm gonna hand back the exams today, probably at the end of class. Um, Tell you a little bit of a policy that I have with my exams, what I do. So I'm gonna give you back the exam. If you're happy with the grades you got, yay, good job for you. Right? If you're not happy with the grade, right? what I'm gonna allow you guys to do is you can go to tutoring, right? And you can do all the questions that you got wrong with the tutor, and then you bring it back to me and let me see, and I'll give you back half of the points that you missed, right? So you figure if you got like, let's say, I don't know, a 50 on this exam, right? And then you went to the tutor, you worked with them, you did all the questions you got wrong, you brought it back to me and I checked it and all that, then I'll turn your 50 into a 75. You know? And vice versa, you know?
Yeah, that's one.
I mean, if you got a 20, then you'll go up to a 50. Not so bad.
Not bad.
Well, no. 60. Math is bad. Yeah. Yeah, so we'll deal with that later. But for now, back to homework. Any questions? Go ahead. Yeah, ask. Go ahead. 9x plus 2? Oh, cube. Got you. Four x squared. What is 4x? Okay. That's it? Then this is it? All right. So first thing I want to do here, right? You want to look for the greatest common factor, right? GCF, right? Looking at this, what would you say the GCF is? X, right? So I'm gonna pull out the X over here. So now when I pull out X, what's left over? I'm gonna have 9, what? X squared minus what? Minus 4. And that's it. Now, looking at the 9x squared minus 4 part alone, right? What do I see? Like, what is that? Right, that's the difference of two perfect squares. So I know that my answer is going to be what? 3 what? Uh-huh. Minus 2. What's the other one? Right, plus 2. Right, so these are going to be conjugates, right? Because when we have the difference of two perfect squares, it's the same thing, but one is a minus, one is a plus. It doesn't matter which one you put first. Oh, good. That's it. So yeah, you just type that in for web work and you'll be good to go.
So everything.
Mhm. Mhm. Yeah, if possible. If it was a sum of perfect squares, that I can't factor. Just leave that alone. So like if it was same thing, say that it was like 9x squared plus 4, that can't factor.
Okay.
And that'll be the end of it. Yeah, that plus and minus sign is really important. Okay, what's the other one? Yeah. R squared? I? Oh, y squared. Got you. 11y? That's it? All right. So this one now, this is more like our homework from yesterday, right? We want to solve for y here, right? And there's going to be two answers here. Couple ways we could do this. We could do the AC method, right? An easier way to do it though, greatest common factor. And we should be looking for that in the beginning anyway, right? GCF. So what's the greatest common factor here? Y, right? So I'm gonna factor out y. What am I left with? Y minus 11, excellent, is equal to 0, right? All you have to do at this point is just solve for y. So on one hand, you have y is equal to 0. That's a whole answer right there. And then on the other hand, you're going to have y minus 11 is equal to 0. You're going to add 11 to both sides. So you're going to have y is equal to 11 as your other answer. And then that's it. I'm not sure how they want you to type that in. Maybe they want like a 0, 11 or something.
Well, we can see the green on worst case.
I couldn't figure it out. My fault. Doing both answers? Yes, you will. But I know sometimes they're a little funny. They'll be like, oh, put the small answer first and then the large answer after or something like that. Any more? You guys are welcome to ask as well. Like, no problem. That's fine. That's fine. I mean, even if you have old questions, I'll take that too. It's no problem. Yeah. All right. All right. So 6x equals 11x squared. All right. Not too bad, right? Same thing. I want to put everything on one side first. So I'm going to subtract the 6x over here. If I do to one side, do to the other. So now I have 0 is equal to 11x squared minus 6x, right? First things first, we should be looking for, right? GCF. So what's the greatest common factor here? X, right? So now I have 0 is equal to x, open parentheses, what? Exactly, right? And then now, individually, right, individually, you want to set both of these equal to 0. So I'm going to have x is equal to 0, and I'm done. That's one answer. And you're going to have 11x minus 6 is equal to 0. Then we just want to solve for x. So how do I solve for x? I want to add 6 over here. What I do to one side, I got to do to the other. So I have 11x is equal to 6. Then I want to divide by 11. What I do to one side, I got to do to the other. So I have x is equal to 6 over 11. Okay? And that's it. To solve for x.
Yeah, like that. You made like a little guide on how to do long division problems.
Long division problems. All right,
Like a step by step type thing.
let me see if I could get you something like concrete how to do
So
it. Yeah,
those thinking like there's so many things going on up top, bottom.
I got you. All right, just bear with me one second, guys. I'm looking for something. Hey, how you doing, man? Hmm? Oh no, this is questions. Just questions. I got you. I'm 1 second. 1 second. All right, so what I'm gonna do in the next what's it called? Um announcement that I make, right? I'm gonna put a video for the long division. All right, go ahead. Six what? 16. That's it? All right. What I would do here though, right? Really don't like negatives. Mm, Actually, that's not even a problem. First things first, right? Always start off with this GCF, right? So what's my greatest common factor here? Mhm. No, 4, right? So I'm going to factor out a 4 here. What's left over? No. Okay, minus 1x what squared, right? Equals 0. All right, not so bad, not so bad. Right? Now, what do I want to do? You could factor this, right? So what's the factor of this? Oh, 2 what? Minus x, okay, and what else? Exactly, right? Difference of two perfect squares. After that now, individually, right? This is actually a question I wanted to show you guys yesterday, right? You see how I have that 4 out there, right? The 4 is not bothering me in my answer. So you're just setting what's in the parentheses equal to 0. And then just solve for x. That's all you have to do. So I'm gonna add x over here. What I do to one side, do to the other. So I have what x is equal to 2 over here. I'm gonna subtract 2 from over here. What I do to one side, do to the other. So I have x is equal to -2, right? So boom, boom. Yeah.
Can I ask you about
Yep,
division? I think
sure.
often they come just like,
I'm gonna put a video up about it, but yeah, ask please.
oh, for Europe.
Huh? No, no, no. I'm gonna put a video for the next announcement on the long division. Yeah. Complicated video, but a video. But all right, yeah, go ahead. What's your question?
So X two
Okay,
positive 9x
okay,
positive 19
okay.
divided by x positive 3.
All right.
So,
First thing I like to do with this, just to set it up real quick. The denominator goes on the outside, so I have x plus 3 right here. And then the numerator, that's gonna go on the inside here. X squared plus 9x plus 19. Right? And then now let's do the long division.
So it will be, the first one will be x.
Right? So x goes into x squared x times, right?
Yeah.
And then x times x
Two x two
is x squared, very good. And x times 3 is what?
3
3 what?
x.
3x, right? So that's going to be plus 3x right here, right? But now, what do I want to do? Remember, this is a polynomial. So I want to subtract these from one another, right? So x squared and x squared will cancel out. 9x minus 3x is what?
And
9x minus 3x is what?
6.
6x, right? And then what I want to do is I want to bring down this next number here, plus 19. So now x goes into 6x how many times?
2.
No,
6.
no. So, right, I want to know how many times x go into 6x?
6 times.
6 times, right? So positive 6. So now, what do I do? 6 times x, that's 6x. And then 6 times 3, what's that, 18? Something like that? Yeah. And then remember, this is a polynomial, right? So I want to subtract these. So 6x minus 6x cancels out. 19 minus 18 is what? 1, right? So boom. So over here, your quotient, Q-U-T-I-E-N-T, something like that. This right here, this is your remainder. And that's it. Why is 19 minus 18? So that's just the process with division. When we do long division, right? We always subtract the next number that we get out of it. Right? All right, let's try another number. I'm just gonna make up something. Let's say I have 6 into 36. I don't know, I'm making it up. Right? 3,300, excuse me, 3,636, right? So if I was to do this question, right? First, I would look at the 6 and I would ask myself, how many times does 6 go into 36? I know that 6 can't go into 3, so I don't even waste my time on that. How many times does 6 go into 36? Right? It goes in 6 times, right? So I put that 6 up top, right? Now, 6 times 6, I'm combining these two, right? 6 times 6, that's 36. So I put that 36 right here, right? Right underneath the 36 up top. And then I subtract them. 36 minus 36 is 0. And then I bring down the next number. My next number is 3. Now 6, this 6, goes into 3, right? How many times? Nope. 6 goes into 3 how many times? No. It doesn't, right? That's 0, right? And then 0 times 6 is 0. And then I'm going to subtract this, right? So 3 minus 0 is 3. Bring down the last 6. Now 6 goes into 36 how many times? 6 times, right? So I put that 6 up here. And then lastly, 6 times 6, that is also 36. Subtract this, and then that's 0, right? This is the quotient. This is the remainder.
So, okay.
Mhm.
Pretty much like the opposite of like distribution for
Right.
multiplication and division.
Exactly.
So 6 goes on 36. So you put that there.
With the x, yeah, it's the same idea, the same principle that's going on, right? It's just that you're subtracting a polynomial from a polynomial, right? So remember, you have to like distribute that negative and then combine like terms and all of that. But what I do, you can follow me for a second. What I like to do, right, is I look at the first part that I'm gonna subtract, and then I subtract it from the bottom part here. So I say x squared minus x squared, and then that's how I am able to cancel this out. Then for the next question, the same thing, right? I say 9x first, then I say minus, and then I say 3x. So 9x minus 3x, and then that's how I get the 6x right here. That's my process. That's how I go about doing it.
Fair.
Mhm.
So 9 minus 3 is 6, right?
Yeah, correct.
So you say 6 divided by 3, not 3 divided.
Like, what do you mean? Like to get the 6 below it?
Yeah.
Oh, okay. So to get the 6 on top, right? I want to know what is 6x from here divided by the x from here. Right? So 6x divided by x, that's just 6. This 6 here now is the one that goes here. Now, I'm not doing it vertical like that, kind of like just doing it in my head, like, oh, 6 times x is 6x. And I'm just writing it up top. But fundamentally, this is the process of what I'm going through. And this works with any polynomial, any monomial, it don't matter. This one process of long division works for all of them. Well, me personally, be honest with you, this is my favorite division. You're gonna learn about another division when you get to math 30 called synthetic division. I hate that. This, yeah, this is the bomb. You did? Oh, you lucky. Yeah, I hate that division. With the coefficients and all that. Nah. So let me tell you why I don't like it, right? It's a trick. That's why I don't like it. It only works when you know a root from the whole polynomial, right? You can only test, like that's a better word to say it. You can only test one root in the polynomial at a time. But you see, like with this long division here, right? Matter of fact, I think we even have a previous question. I'll show you right now. It was earlier.
So you almost supposed to do that not 30.
Yeah. Wait, it's not here, but you guys seen in your homework, right? Where some of the divisors, the numbers on the denominator on the bottom, they're to like the second power, right? And then you're dividing something to the third power, yeah, like that, right? So you see how that when it's to the second power, you're combining two roots, dividing it from like this bigger polynomial, right? You can't do that in synthetic division. You can only do a single root, and hopefully that works. Then you can do another root, hopefully that works, so on and so forth. To me, it's more work. This one straight process, boom, boom, and you're done.
So this is what I was about to find. Yeah. Right?
Yeah.
And then I was
Be doing
going
this.
next.
Yeah. All right, let's do that one. So,
Class harder.
I mean, some people want you to get like more bang for your buck, I guess. You can say.
Maybe half the pass. Is it all she does?
Wow.
He entered the class early, like, people aren't passing and happy you didn't show up today, so you can leave early, whatever.
Wow. I won't do that because I record the class. You guys can just watch this later. So I'm stealing somebody's homework question right here, right? But you see how the denominator right here to the second power, there's two roots in there, right? I'm trying to figure out what the third root is by doing this division, right? Not so bad. But anyway, long division, right? The denominator, I have x squared minus 2x plus 2. That goes on the outside. And the numerator goes on the inside. X cubed minus 3x squared plus 6x minus 1. All right? And now I just want to divide. So x squared goes into x cubed how many times? X times is what I'm looking for, all right? So essentially what I'm asking you is I'm asking you this. What is x cubed divided by x squared? That's what I'm asking you, which is just x, right? Or x to the 3 minus 2 power, which is x, right? Anyway, that's up top. After I get the number up top, the x, right? I take it and I multiply it to each one of these, right? And then I write the answers underneath this bigger polynomial right here. All right, so let's take a look at that. All right, x times x squared is x cubed. Hold on, I can't write 3 right now. There we go. Right, then x times negative 2x is negative 2x squared. Very good. And then x times 2 is going to be plus 2x. Very good. Now remember, this whole thing right here, this is a polynomial. So I want to subtract this from the larger polynomial up top, right? Now, x cubed minus x cubed is what? Cancels out. So that's the end of that, right? Let's try this again. Negative 3x squared minus negative 2x squared is what? Negative 1x squared, right? Or negative x squared. Very good, right? And then let's try it again. So I have 6x minus 2x. What is that? Right? So this is going to be plus 4x. Very good.
So just subtracting the coefficients of the.
Yeah, that's it. Yeah. And then bring down the extra number that you have here. This case is negative 1. Now, x squared goes into negative x squared how many times? Yeah. X squared goes into negative x squared how many times? Negative, try another one. What would I have to multiply x squared by to make it negative x squared? No. Negative 1. Negative 1. That's it. Right? So what I'm asking you is I'm asking you what is negative x squared divided by x squared? Right? Which we know would just become negative 1. Right? So that's how I get this negative 1 up here. So anyway, negative 1 times x squared, right? So I'm taking it, negative 1 times x squared. That's going to be what? Negative x squared. And then negative 1 times negative 2x is going to be what? Plus 2x. And then negative 1 times positive 2, right, is going to give me a negative 2. But remember, this is a polynomial, right? So I want to subtract these, right? So negative x squared minus negative x squared cancels out. 4x minus 2x is 2x. Very good. Now, negative 1 minus negative 2. What's that? No. So I'm asking you this. Negative 1 minus negative 2. Not 3. So a negative and a negative becomes positive. So this is negative 1 plus 2, which is positive 1. I got you. But that's essentially, that's what I'm asking. That's what I'm asking. And then now you have your quotient, you have your remainder there. Questions on this? I know. I got you. I'm gonna probably post like maybe 2 videos on this. All right. And then you guys can look at it and that should help to clear up the division questions. I do want you guys to master this though. Like for me in high school, this is the only topic I learned and I was able to knock it out, like all the division questions that came my way. But yeah, no synthetic division for me.
Like we parts in that stuff wasn't supposed to be doing.
Mm. I mean, technically speaking, it's in your textbook. You can read about it if you want, but I'm not a fan. So, how can I say this now? I like tricks in math, but I prefer methods that work for all situations.
It's not very like
Yeah.
lie and say like, oh, I can't use this. I wasted some time just
Right.
that this doesn't work.
Like when we were doing the perfect square trinomials, you guys remember that? Right? So with the perfect square trinomials, it's like it's a trick, you know? it comes in handy from time to time when I don't feel like doing work. But to be honest with you, I know it only works in a very special situation when I have my A term for ax squared is a perfect square and my C term is a perfect square. Then I can employ that, but I prefer the AC method overall because that works for all the situations, you know. And even the AC method, I'm not even a total fan of. There's another method that I use for everything else. Y'all learn that at the end of the class. But, yeah, something even easier than that. So anybody else, any questions?
First,
Oh, this one? Yeah.
so it's very external,
Uh-huh.
so then we go to the next one.
Hmm.
So
Like where the negative 2x squared here?
Yeah.
No, I got that one from multiplying the x here by negative 2x. Yeah. It's a little funky, but as you do the practice with it, with the homework and stuff, it'll make more sense. You just gotta practice it a little bit.
Mess up like one more spot.
And then that's
Mess
it.
up that.
Yeah. That's why if you notice in some questions, you see me putting like zeros. Like I'll be like, oh, 0x squared or something like that, right? So I'm trying to do a placeholder so I don't mess up. You know? But that's that. Anybody else? Any other questions? Oh yeah, you said yeah.
I got a 6x.
Wait, hold on. We have what? To the fifth power. Y squared. 200. Like that. So, wow, this is hard. Right? First thing I want to do, greatest common factor, right? Always we're gonna start off with that. Right? So what's the greatest common factor here? Three x y squared. That's perfect. That's actually the greatest common factor. It's well done. All right. So then we're gonna divide by 3xy squared. It's like we're dividing by 3x squared, right? Sorry about that little glitch. 3 and 3 cancels out. Y squared cancels out. X to the fifth divided by x is what? X to the fourth. Very good. Very good. And then 243 divided by 3 is what? All right. So negative 81. X and x cancels out. Y squared cancels out. Right? Now, this might look a little like crazy, but this is really the difference of two perfect squares right here, right? Because we know what x to the fourth is, right? X to the fourth is just x squared. Now we know what 81 is, right? 81 is just 9 squared, right? So you know what's gonna happen next. We're gonna have the factor out here, right? And then we're gonna have that plus or minus situation, right? We're gonna have x squared plus 9 and x squared minus 9, right? Difference of two perfect squares, right? But here's the issue, I'm not done. Because technically x squared minus 9, right? That's that's a difference of two perfect squares as well. So now, what do I have? I have 3xy squared, x squared plus 9, right? That's the sum of two perfect squares. We can't do nothing with that. Then I'm going to have a factor here. So what's my factor going to be? X what?
Negative. Or x minus.
X minus X plus, good, what's the number? 3, right? And then that's it. Yeah, I did, it's there. Because it's the factor. It's the greatest common factor. That's the factor that got pulled out. And then that entire thing is the answer. Go ahead.
Sections of
On top.
like what this extra time.
So the x squared plus 9, that can't get factored anymore. But the thing is that the x squared minus 9, that's the difference to perfect squares. That can get factored. Yeah, so this thing became these two. And then this just copied down and that just copied down. Yeah. Gotcha. There you go. Right. So we good? Okay. All right, go ahead. Well, let me go ahead. 6x what? Uh-huh.
Negative parentheses plus x plus
200? Oh, just 23?
So.
All right. So it's not bad. Distribute the negative first. That's the first thing you want to do, right? So I have 6x minus 16 is equal to a negative 11x minus 23. Now, what I want to do is I want to get all my x's on one side, all my numbers on the other. So I'm going to add 11 over here. What I do to one side, I got to do to the other. So what is this, like 17x? Mm-hmm. No, I wouldn't square it. Now what I want to do, I want x by itself. So I'm going to add 16 over here. Add 16 over here. So now what do I have? I have 17x is equal to, what's negative 23 plus 16? Negative 7. And then I want to divide by 17, get x by itself. What you do to one side, you gotta do to the other. Right? So x is equal to negative 7 over 17. And that's it. Hmm? I'll make it smaller so you can see the whole thing.
Whenever there's more than one x, I just start.
Oh no. Just combine them. That's all you gotta do. All right, what's your question? Wait, hold on. Let me just. All right, go ahead. All right, not bad. So basically, it's just a little AC method right there, right? So you can A times C, we know is going to be 1 times 96, which is 96. And then I want my B term, which is 20. So I need two numbers that multiply to 96 and add up to 20. What do we think they are? Not gonna lie, I'm not sure. So I'm gonna use the prime factorization tree. So I have 3 right here, and this should be like what? 32? 8 and 12? Okay. Does it really work? 8 times 12? 6. Yeah, it does. 96. And then 8 plus 12 is 20. Very good. All right. And then if I was, just real quick, if I was gonna break this down, it should be, I think, 16 and 2. And then a whole bunch of twos after that. Anyway, we write this. X squared plus 8x plus 12x plus 96 equals 0. And then group them. The left-hand group, I'm gonna have x times x plus 8. Right-hand group is gonna be what? Plus 12 times x plus, what is it? 8, good. Equals 0, greatest common factor. X plus 8. And then what's left over? X plus 12. All right. Last step, set them both equal to 0. X plus 8 is equal to 0, subtract 8. We do the one side, do to the other. X is equal to negative 8. And then x plus 12 equals 0, subtract 12. You do the one side, do to the other, so then you have x is equal to negative 12. Questions? Mhm. Yeah. Okay. By the way, when you guys are in WebWorks, there's a link on the left-hand side. It's called grades. If you click on that, it'll show you what you're missing, and then you can just go in and do the missing problems and all that. Yeah. Yeah, sometimes you overlook just one question and that's it. Yeah. It happens. Sure. Like you want to make it smaller? Or-
No, I.
Okay. You're welcome. Today we're switching from this. We're done with factoring. We're going into rational expressions. I feel you. Factoring is a challenge. I'm not gonna lie.
I don't remember that.
Yeah, I got you.
Yeah.
That's it. Change flip is the truth.
Again,
Yeah, it's factoring that. But it's like a little bit of factoring. It's not crazy
you cancel
factoring.
out.
Right.
Yeah.
Cancel out the like terms and then whatever's left over.
You should take questions.
Yeah, if you have a question.
Yeah.
I was about to start the lesson.
Oh, I like that.
Thought people would copy. Oh my God. No, 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 no. We gotta finish early today.
Wow.
They said rain.
It is.
Yeah.
What percent?
I don't know. Google just said rain at 8. I feel sorry for them in their movie. Right? All right, let's start off the lesson real quick. We'll do more questions at the end. Okay. So this is what we're getting into. Might not finish it today, but we're gonna start it at least. All right. So we previously reviewed the properties of fractions and their operations, right? We introduced rational numbers, which are just fractions where the numerators and denominators are integers. In this chapter, we will work with fractions whose numerators and denominators, are polynomials, right? I promise you, it's not that bad, not that bad, right? And we call this kind of expression a rational expression, right? Real quick, y'all know I like my little definition. So rational expression, a rational expression is a expression of the form P over Q, where P and Q are polynomials and Q cannot equal zero, right? Q cannot equal zero. I just want to show you guys some examples real quick. So for example, these are rational expressions. So if I have, like, for example, negative 24 divided by 56, right? That's a rational expression. 5x divided by 12y, rational expression. 4x plus 1 divided by x squared minus 9, rational expression. 4x squared plus 3x minus 1 divided by 2x minus 8, rational expression. All right? So that's what we're getting into right now. All right, so we will do the same operation with rational expressions that we did with fractions. We will simplify, add, subtract, multiply, divide, and use them in applications. Determine the values for which a rational expression is undefined. If the denominator is 0, the rational expression is undefined. Say it one more time. If the denominator is 0, the rational expression is undefined. The numerator of a rational expression may be 0, but not the denominator, right? It is illegal for my denominator to be 0. All right? Yeah. So give y'all a little bit of instructions before we jump into anything. It's a little how-to. So how to determine the values for which a rational expression is undefined. Step 1, set the denominator equal to 0. Step 2, solve the equation. That's it. All right? So I'm going to give you a rational expression and I'm going to ask you, what would make this question undefined, right? All you're going to do is you're going to take the denominator, set it equal to 0, and then you're going to give me back that answer, all right? So let me show you what I'm talking about. So we want to determine the value for which each rational expression is undefined, right? So I'm going to start off with A, for example, right? So for A, I have 8a squared b divided by 3c. I do not care what the numerator is. I care only about the denominator. You're going to take the denominator, bottom part right here, and you're going to set it equal to 0. So 3c is equal to 0. And then you're going to solve for c. So I'm going to divide by 3 over here. What I do to one side, I do to the other. So c is equal to 0. So what does this mean? This means that whenever a value of 0 is given to c, this rational expression is undefined. That's what it means. Like it is illegal for me to say C is equal to 0 in this rational expression. All right. Let's try another one. Let's look at B. I have 4B minus 3 over 2B plus 5. And my question is, when is this rational expression undefined, right? So to figure that out, what I do, I'm going to take the denominator. What's the denominator here? 2B plus 5, very good. I'm going to set that equal to 0, right? And after that, all I want to do is I want to solve for B. So I'm going to subtract 5 from over here. When I do to one side, I do to the other. So now I have 2B is equal to -5. And then after that, what do I want to do? Divide by 2 to get B by itself, which you do to one side, you do to the other. And then that's it. B is equal to -5 over 2. Right? So what does this mean? This means that B can be any number it wants to be, but it cannot be -5 over 2, because if it's -5 over 2, the denominator of this rational expression will be undefined. Right? Let me look at C now. So for C, I have x plus 4 over x squared plus 5x plus 6. Right? My question here, I want to know, when is this problem undefined? So what do? I'm going to take my denominator, right? Just the bottom number here, or expression, x squared plus 5x plus 6. And I'm going to set that equal to 0. And I want to solve for x, right? So we can solve this by factoring. We know that this is going to become what? X plus 2 and x plus 3 equals to 0. And then you just set each one of these individually equal to 0. X plus 2 equals 0 and x plus 3 equals 0, right? Just solve for x. I'm going to subtract 2 from over here. What I do to one side, do to the other. So I have x is equal to -2. Over here, I want to subtract 3. What I do to one side, do to the other. So x is equal to -3. So, go ahead. I factored it.
6.
So I found two numbers that multiply to 6, 3 times 2. And when I add them together, it will give me 5. Sure, if you know how to do another way, go ahead. You want to do the AC method, go right ahead. No? Like I was just doing a shortcut. It's another method called trial and error. That's what I was doing. But we didn't learn that. So yeah, you find the two factors, you set them equal to 0. That's your answer. So what does this mean? This means that x could be any number it wants to be, but it cannot be -2 or -3, right? Because at those two particular numbers, this expression here, rational expression, is undefined. All right? Questions on this?
What happens to the top one?
I don't care what happens here. Yeah, just the bottom.
What would be the question?
So the question is like, at what value is this undefined? All right, determine the value for which the rational expression is undefined. So in part C, it's undefined at x equals -2 and x equals -3. Alright, you guys try. Yeah, I'm like looking, I see clouds. The wind don't look strong enough though.
Gonna have a concert.
I don't know. That's what I was thinking. It looked like they're building a stage. Yeah, I'm not sure. I know that they're doing a movie or not movie, like a TV show, like series or something. Yeah. They said it's on Netflix though, so I'm like, yeah. Huh? Recess or something? No. Netflix show. Recess. Yeah. That would be fire if it was live action. Yeah.
Damn, I don't got a video.
That's what it said?
It's a severe thunderstorm watch.
Oh, snap.
Say one.
So 12.
Oh, yeah. It's like 12. I think that's like 12. Tomorrow.
Right? About to Google that right now. How we looking at with the weather? It's not so bad. Like looking at the precipitation, it's not too bad. So between like 9 p.m. and 10 p.m. it's supposed to be like it's supposed to pick up, but then it's gonna like die down. But you see like 1 a.m. That's what's gonna be real. Between like 1 and 5. Yeah, I think we're gonna be alright. I don't think it's that bad. And the wind is not even that strong, so yo, I'm not gonna lie, I'm hyped about tomorrow night. Oh, about to have that presidential debate. It's gonna be lit.
Was it Biden quicker?
Yeah.
Why is it done?
And
Can't be no let it do. I feel like it's already done. Like,
because they're former presidents, like they have so much
following.
following, that's a good word. That, like I feel like if anybody else tried to run against them, they couldn't win, kind of thing. So it's just like let them have their moment to shine, and then when they're done, then somebody else will come in.
Sure.
A conservative is like right side, like Republicans.
The folks that are like, you know, like,
The
say like
liberals.
policies for both sides.
The liberals.
Let's take off.
Yeah.
We're like, look,
Huh?
I've seen them make bad jokes about them.
Yeah. Like liberals, they're not for any one party, but like they like viewpoints from both and stuff. Nothing is wrong with that.
I see bad, like, people like, they make fun.
Sometimes like young liberals will do things and it's like they don't know the full reason or picture why they're doing it kind of situation. So that's why they make fun of them a little
Yeah, they put on little parts.
bit. like, I mean, but when you get more educated, it's not bad to be a liberal. It's just you just have to know what you're standing for and what you're doing. I don't even know. I might just flip a coin when I go in there.
It's
Like,
pretty bad. Wait, how's he gonna be president? Is he president in jail? Or you can't jail president.
but isn't it like there's like this gray area though, right? So as a president, you have the power to veto people. Like so if I was president and like let's say you like kill somebody and you on death row, like I could really come in there and just say like I pardon you. And then you could just walk free.
That's what Trump did, so.
Yeah. But the question is though, right? Like there's a gray area. Can Trump pardon himself? There's nothing written that said that he can't do it. No. No. But if he got elected again, could he pardon himself?
He's smart.
That'd be crazy. What if they put him in jail before that? I would pardon.
I mean, but if he's in jail as president, couldn't he just pardon himself?
That's crazy.
And then like
To think about it.
if they like really I can't picture them putting him in jail. Like that would literally mean that he would be in jail with his own security team to protect him.
Because he's
Secret
Service, right?
Like, cause he's a former president. Like
Yeah,
he has that all the time. Even Barron has Secret Service, I think, so he finishes college. So yeah,
Blueberry, son.
his son, yeah. Yo, he's mad tall. Like, I don't know where he got that height from, yo. Maybe, like, I don't know where he gets that height. Like, he's ridiculously tall.
Does he have orange skin?
Huh?
Does he have orange skin?
Nah. But he has like the same kind of like, there's like a look that Trump has in his face, like a smug, satisfied kind of look, kind of thing. Like I don't know. He has that same kind of look, in my opinion, in his face. All right, so let's look at A, right? I have 3y squared divided by 8x. Again, I don't care about the numerator. All I care about is the denominator. When will the denominator be undefined? When will the denominator be 0? So I take the denominator, 8x, I'm going to set that equal to 0. Divide by 8. What I do to one side, I got to do to the other. So I have x is equal to 0, right? This is the value at which this rational expression is undefined. That's the answer. That's it. Let's look at B. For B, I have 8n minus 5 over 3n plus 1. I do not care what the numerator is, just the denominator, right? I'm going to take the bottom number, right? The 3n plus 1. I'm going to set that equal to 0. So I'm going to subtract 1. What I do to one side, I got to do to the other. So I have 3n is equal to negative 1. Then I want to divide by 3. What I do to one side, do to the other, right? So I have n is equal to negative 1 over 3. This is my answer. All right? So n can be any number except negative 1 over 3, right? Because that'll be undefined. Let's look at C. Bear with me 1 second. A plus 10 over A squared plus 4A, and I think that's plus 3. Yeah, plus 3. Okay. For C, this is the same thing. This rational expression, I don't care about the numerator, the number on top. I only care about the bottom, right? I'm going to take the bottom. I'm going to set that equal to 0. So A squared plus 4A plus 3 is equal to 0. After that, what do you want to do? Let's factor it, right? You could use the AC method. I'm going to use trial and error. I know that this is A plus 3 and A plus 1, right? Is equal to 0. How do I know that? Because 3 times 1 is 3, and 3 plus 1 is 4, right? That's trial and error for you. Anyway, we set both of these equal to 0. A plus 3 is equal to 0. A plus 1 is equal to 0. And then you just solve for A. I'm going to subtract 3. Or we do the one side, do to the other. So I have A is equal to negative 3. Over here, I'm going to subtract 1. When I do the one side, do to the other. So I have A is equal to negative 1. This right here is my answers. So A could be any number it wants to be except these two numbers, negative 1 and negative 3. Because those numbers will make the denominator 0, which will make it undefined. All right? Does this make sense? Everybody got these answers? Yeah? All right. Huh? I'm sorry? Not for this. Not for this. But we're gonna like take this idea a little bit further real quick, right? So what I want to do next is I want to simplify rational expressions, right? So remember this, a fraction is considered simplified if there are no common factors other than 1 in its numerator and denominator. Similarly, a simplified rational expression has no common factors other than 1 in its numerator and denominator, right? So let's take a look at what I'm talking about. I know we remember this from the numbers, but let me show you what it is from the polynomials real quick, right? So let's say I have x plus 2 over x plus 3, right? It's simplified because there are no common factors of x plus 2 and x plus 3. But 2x divided by 3x is not simplified because x is a common factor of 2x and 3x, right? The x's can cancel out, leaving back just 2 over 3. All right? This is what I'm talking about when I say simplified a rational expression. All right? Just checking. So I want to talk to you about the equivalence fraction property. So let's say if A, B, and C are numbers where B cannot equal 0, C cannot equal 0, then A over B is equal to A times C over B times C, and A times C over B times C is equal to A over B, vice versa, right? This is going to be very, very useful to us in a second. You're about to see. Okay, so to simplify rational expressions, we first write the numerator and denominator in factored form, right? Then we remove the common factors using the equivalent fractions property. Be very careful. As you remove common factors, factors are multiplied to make a product. You can remove a factor from a product. You cannot remove a term from a sum. Remember that. Cannot remove a term from a sum. I know somebody in here is going to make that mistake. I don't know who it is, but somebody in here is gonna make that mistake. Let's talk about it a little bit. Let's talk about it a little bit. All right, so let's take a look at this. I have, for example, 2 times 3 times 7 divided by 3 times 5 times 7, right? I have a 3 on top, a 3 on the bottom, so I cross them out. I have a 7 on top, a 7 on the bottom, across them out. That reduces to 2 over 5. So we remove the common factors of 3 and 7. They are the factors of the product. Looking at the second one now, I have 3x times x minus 9 over 5 times x minus 9. X minus 9 and x minus 9, right? They're the same, right? So I'm going to cross them out, right? Where 9 cannot equal 0. That reduces to 3x over 5. So we remove the common factor of x minus 9, and it is a factor of the product. But let's say I have x plus 5 over x. There's no common factor there, right? But I know somebody in here is wanting to do this. I don't know who it is, but somebody in here wants to do that. No, can't do that, right? Why are you not erasing? Oh, I hate you, Microsoft. There we go, right? This right here, the numerator is a sum. It's together, right? And the x right here on the bottom is by itself. You cannot break the sum, right? It has to be the same thing in parentheses for it to break. All right. So let's see. No common factors. While there is an x in both the numerator and denominator, the x in the numerator is a term of a sum. Okay.
Basically, get rid of the X
Hmm.
make it just X,
Right. Like an x from an x or something like that.
or X plus 5. X plus something, it's a sum.
Right. It's a sum. Let's try it out. Hold up. So look at this. I have x squared plus 5x plus 6 divided by x squared plus 8x plus 12. All right? Real simple, real simple. All you got to do, factor the numerator, factor the denominator, right? Let's look at what the numerator is going to be. Tell me what it's going to be. It's going to be x, right? 3 and 2, very good. Plus 3, plus 2. Very good, right? Because 3 plus 2 is 5, and 3 times 2 is 6. Very good. What about the bottom? Let me see if you can get that. X, 6 and 2, very good. Plus 6 plus 2, very good, right? Because 6 plus 2 is 8, and 6 times 2 is 12. Excellent. Do I have any common factors here? What are they? Right? X plus 2 and x plus 2, right? These will cancel out. So what is my final answer in a simplified form? Uh-huh. And x plus 6. Very good. That's my final answer right there. Is there any questions on this? Anything? So we good? All right. You guys try. I know you see me using a shortcut here to factor and all of that. If that's confusing, go back to what you know how to do. Go back to the AC method. It'll work. All right. What happened? I think 8. Like it's weird. Like looking out, it looks like it's gonna start. The fact that he's sitting under the tree doesn't help. You know? So I'm like, why would you sit under the tree at night? Must be because it's raining, you know?
Isn't that like the worst place to sit though?
Oh yeah, that's
The
true.
mountain.
Yeah, that's true. I mean, for us in the city, we got these tall buildings, so Meister Hall get hit before he gets hit. Yeah, it is the worst place to sit.
Yeah, it was a earthquake. If I thought it was not my. It was just an earthquake. There was a lot of, like, state.
Oh wow.
Every other class level. It's trash.
Wow.
So it was true.
I mean, the best thing to do is like the door frame. You know, stay right there or get underneath the table.
I don't know. I heard that like they used to tell people back in the day, like when you do it, like stuff starts crashing.
Oh no.
Oh, no, no. I'm thinking about they used to do the table.
Nuclear bomb. Yeah, the nuclear bomb and all that. Yeah.
Get on the table.
I'm guessing like if stuff crashed, the table might protect you a little bit,
They
kind of, sort of. Might,
crash
might,
the
yeah. All right, let's take a look at this. Not so bad, right? A fact at the top, fact at the bottom, right? So for the top, what I got? Very good. And what? Very good. Well done. And what about the bottom? Very good. Very good. Very good. Very.
Push.
Mhm.
One minus.
For which one?
Yeah,
Mhm. So remember what I want, right? I want two numbers to multiply to give me -2, but then when I add them, they have to add up to -1, right? So -2 times +1, that's -2. And -2 plus +1, that's -1. So that's the reason why.
the light on one side, the same.
Same thing.
We still cancel them.
Yeah, you can cancel on the other side. That just happened to be that way, you know?
No, I'm saying like for this.
Yeah, like if this was like +1 and -2 over here, that's fine. Yeah, that's fine. It'll still cancel like that. The ones can't cancel, right? Just the x-2 and the x-2. Right, like that's a sum, right? X plus 1 and even x-1. That's not the same thing. These can't cancel. Yeah. So that's the final answer right there. Let me give you guys a little procedure real quick. So this is just the notes of how we're doing what we're doing. So how to simplify a rational expression. So step 1, factor the numerator and the denominator completely. And then step 2, simplify by dividing out the common factors. That's it, right? Simplify a rational expression. Let's take a look. Whoops. Okay, so I want to simplify this. It looks scary, but it's not too bad, right? What's the numerator gonna be? Mhm. What should I do first to factor it? What do I always do before the AC? What do I do? Greatest common factor. So what's the greatest common factor here? Just three, right? Oh my gosh, why are you not writing? There you go. Three, right? So what's left over? I have a squared minus, what's this, 4ab? Whoops, sorry. Plus 4b squared. How about the denominator? What's the greatest common factor there? Six, right? I'm gonna factor out a six. And that leaves back what? A squared minus, what's this, 4b squared? Am I right? And then just to save time, I'm gonna use the trick. But if you're not comfortable with the trick, you already know AC method works every time. This is A and A, right? And then what's this gonna be? 2B, 2B, and they're both gonna be minus. All right? That's the perfect square trinomial that I was talking about earlier, right? It's a trick. It only works in this particular scenario. If you're not comfortable with that again, AC method, it'll work. All right? Nothing wrong with the AC method. I'm just pressed for time because class over in a couple minutes, all right? So let's look at the bottom. I have A minus 2B, A plus 2B. That's the difference of two perfect squares, right? Now all I have to do is cross out the like terms. So what are the like terms here? I have an A minus 2B and an A minus 2B. Let's cross them out. Bam, right? What else is a like term? I have this 3 right here. 3 goes into 3 once. 3 goes into 6 how many times? 2 times, right? So here's my final answer. It's going to be A minus 2B over 2 times A plus 2B. That's the final answer. Any questions on this? Go ahead. Like a big two? The big two, so the big two outside will kind of be thrown onto the numerator, you know? This is like actually like a 1/2 kind of situation that's going on. Yeah. Does this make sense? Okay. Yeah. You guys try. I'm sorry? Like maybe 30 minutes away. When there's traffic, it's an hour. Yeah, the east side of the Bronx. I mean, it's not that bad, but like the fast way here is across Bronx with no traffic, you know, which like never happens except on like Sunday nights or something.
By as far as
But that's not bad. Yeah.
I was
It's
yeah,
like-
I was sitting on the bus stop. And someone like I'm not sure if I'm in the same place I had the last time.
Yeah.
Maybe I knew him. But he just started nodding his head while he was driving by. I was like,
Wow.
It is bad over there.
I feel you. I mean, even over here, like BCC is beautiful, you know, but you go like two or three blocks in any direction from the school and it just changes. You know, like
Oh,
yeah.
what else?
Wow. One of those things.
Like that.
Yeah. All right, let's knock this one out real quick. What should I do first? Good, good, good. What is it? 6 for the top one? That's not 6. 2, right? Yeah,
Close.
yeah. And that leaves back what? X squared plus 9y squared, right? How about the bottom? 3. Okay, I like that. What's that left over? 9y squared. Perfect. Now we're going to factor this. In the interest of time, I'm just going to use a trick. This is going to be x minus 3y minus 3y over 3 x minus 3y x plus 3y. Did everybody get that? That's fine. That's fine. And then we just cross out the like terms. And then that's it. Final answer, 2 times x minus 3y over 3 times x plus 3y. Notice that you don't see me distributing it back and all that, right? I leave it factored. That's how I want these answers. Leave them factored. All right. All right, let's talk about a rare and unique situation now that can happen. This is not a trick. This is like something that just can happen, right? So opposites in a rational expression. So the opposite of A minus B is B minus A, right? So if A minus B divided by B minus A, that's going to be equal to -1. Of course, when A does not equal B, right? So an expression and its opposites divide to -1, all right? Special little rule, write it down somewhere, you know?
Also, like if you had a positive,
Like if they were opposites. So let me show you. Let me show you. With the variables, yeah. Let me show you. Let me show you. Let's say I have a question like this, right? So I got x squared minus 4x minus 32 divided by 64 minus x squared. So for the top, right? What's the factors? What do y'all think? I need two numbers that multiply to 32, but when I add them together, give me a -4. I know this is gonna be an x here, x here. I'm gonna have a plus, I'm gonna have a minus because I have a -32. So one has to be positive, one has to be negative. The larger number is negative. So what do we think? All right, I like that. -8. Right. It's not writing. Oh, Microsoft. It just be like that, right? All right, so x plus 4, x minus 8. Boom. All right, good job. It's projected? No, projected's fine. That's just fine. All right, denominator, I have 64 minus x squared, right? This is the difference of two perfect squares. So we already know what this is going to be, right? This is going to be 8, right? Minus x and 8 plus x, right? Did I lose anybody?
Yeah, back to the
Well, these, yeah. So what's happening here, right? Real quick, I have the x plus 4. Nothing's wrong with that. And I have this 8 plus x. Nothing's wrong with that. But this part here, this x minus 8 and this 8 minus x. You see how they're opposites, right? So what's going to happen is they're going to become -1. So the final answer for this would be, for example, negative of x plus 4, excuse me, over 8 plus x. So that's what they mean by the opposites. All right? Yeah. Like make it smaller? You want to see it? So if you were to, I'm gonna describe this now. Say I wanted to make either the top, the numerator, or the denominator, doesn't matter. I wanted to make it look like the other, right? Either I want to make the numerator like the denominator, or the denominator look like the numerator, right? If I multiply one of them by -1, I could get them to look the same. But by me multiplying by -1, those two will cancel out, and the -1 will remain. That's what's happening here. Right? It's kind of like doing it as a single process. Couple years now, maybe about 3 now.
You haven't been teaching at 30?
They never offered it to me, but if they did, I'll take it. You guys try.
Trying to see my chance getting you from at 30. That'll be too high. 3 years?
At 30 is fun though, man. You don't like it.
Are you serious?
Yeah.
Someone in my science class said that.
It's mad easy to get to this.
You mean that because once you learn this, it makes everything easier?
Both. We'll go with both.
Calculus, easy.
Way easier than that. Like when you're taking calculus, like you be in the middle of it, just like why did I have to go through all of this just because, you know?
So what's if all has this class?
Yeah,
It's just easy, right?
pretty much.
Well, depending on your professor, right?
Trigonometry, yeah, in the end of it. Yeah. We're gonna do a little trigonometry in this class too, though. Just the beginning of it. We're not gonna go in depth. But a little something. Yeah. Yeah, in math 30. Yeah.
I had something on my finals. It's like something about solve for this triangle, form 1, form 2, something.
Something like that we're gonna do. Yeah, like a similar triangle kind of thing.
He gave the people in class the answer for that one because no one, everybody was leaving it blank.
Maybe when he was doing the class, he didn't have enough time to cover it.
Yeah.
That happens sometimes. All right, we good. Looks dry still. Right. All right, let's take a look. So I have x squared minus 4x minus 5, right? What is that? X plus 1, x minus 5. That is excellent. How about the bottom? What we got? X 5 plus x. That's very well done. Good job. Right? So now, the x plus 1 and the 5 plus x. Nothing's wrong with that. That's cool. Right? But this x minus 5 and this 5 minus x, this could simplify down to -1, right? So now you can rewrite this as, let's say, like -1 times x plus 1 over 5 plus x. And that's it. Nah, you can just leave it like that. You can put the negative sign there, or if you want to put the negative sign out here, you could. It don't matter. Same thing. Right?
This is still rational, but.
Mhm. Yeah. This is a polynomial divided by a polynomial.
It's a little bit, but,
Yeah.
or is it just for the specific situation?
Well, yeah. This is for this particular situation, but we're still canceling out. You know, so this is how you simplify rational expressions, right? The next thing we want to get into is multiplying rational expressions. But I'm kind of looking at the time. I'm thinking we might not be able to get deep into that. Might table that for another day. Yeah, so let's call it at that. So I'm gonna give back your test. Is anybody still copying? Can I take this down? I can start the recording. Go ahead. All right. Take your time. Take your time. All right, I'm good. Okay, I can take it now. Good.